The question asks about a 21 centimeter diameter disc that rotates through an axle in the center. So the question wants to know what is the net torque about this said axle. So here's a picture I drew of the axle and what it looks like. And as you can see, there's multiple torques acting on it. And we basically have to sum them together and solve for the net torque about the axle. And there's two kind of basic ideas that's really important here. One of them is rotational motion, which we've been talking about a lot. A lot of parallels can be found between rotational motion and linear motion, especially with how like units change and variables change, but they still follow pretty similar formulas. Another big thing here is the idea of the summation of torque, which is pretty similar to the summation of forces. So, solve the problem, we need to sum the torques. And in order to do this, we would simply add the torques that are positive and subtract the torques that are negative. So we'd say the counterclockwise direction is positive and the clockwise direction is negative. So the counterclockwise direction, for example, would be that one force at that 45-degree angle, as we saw in the other slide, and also the force at the 90-degree angle. That is 0.05 meters away from the center of the axle. And these would be added to the net torque because they're in the positive direction. In the negative direction, there'd be the 0.105 times 20 times sine 90, the 20 Newton force that we saw in the diagram before, because it is in the clockwise direction. And finally, there's that one force which has sine of 0, and this equals 0 basically because of how the math works out, because sine is 0 when it's sine of 0. And in this problem, the torque, the summation of the torques ends up being 0.46 Newton meters. So there's a few common mistakes when you do this problem. One of the most common mistakes is mixing up the positive and the negative torques. And that's a pretty big error, especially if you mix them up and then get the wrong value. It's a little more confusing in the scenario because we're dealing with torques, and the positive and negative direction is not particularly intuitive because of the way rotational motion works. And along with this, we also have to realize that the 20 Newton force does not contribute to the torque. It is a net force, but it doesn't really go and contribute to rotational motion because the angle of it is sine 0, and sine 0 is also 0 with the zero product property. It multiplies out to be 0. So these are two common mistakes that a lot of students might make when solving this problem. Thank you.